The factory centers its operations around silicon, a crucial material for the production of microchips. It consistently strives to enhance the number of circuits integrated on chips, a vital innovation necessary for preserving a competitive edge in the technology sector. Moreover, production stability holds paramount importance. Even minor disruptions can precipitate substantial financial losses. This underscores the necessity for reliable energy and supply chain management within semiconductor manufacturing processes. Delving deeper into the intricacies of microchips, one observes billions of microscopic switches contained within them. These switches facilitate a myriad of applications, ranging from telecommunications to military operations, thereby underscoring the critical role microchips play in modern electronics. In Taiwan, Micron has established 2 manufacturing plants, which exemplifies its unwavering commitment to the region's semiconductor industry. This development not only fosters technological innovation but also generates numerous employment opportunities. The design process associated with semiconductors is notably complex, involving billions of transistors. It necessitates meticulous planning, akin to the detailed considerations required in the construction of a skyscraper. In addition to design, strict cleanliness protocols are crucial in the semiconductor manufacturing process. Even the most minute dust particles can compromise production integrity, highlighting the importance of maintaining sterile environments. To facilitate this level of cleanliness, a specialized shower system is employed, which eliminates particulates prior to entering the clean areas. This system utilizes high-velocity filtered air to ensure an optimal contamination-free environment. The role of sophisticated machinery cannot be overstated in the fabrication of semiconductors, as these machines actualize design innovations. The advanced technology utilized is capable of creating features that are thousands of times smaller than the diameter of a human hair. Furthermore, automation is integral in minimizing human interaction with wafers, effectively reducing contamination risks. These automated systems not only enhance operational efficiency but also safeguard the integrity of the production line. The factory floor is equipped with an extensive network of over 50,000 sensors and 250 million control points, generating a massive data flow that reaches up to 30 petabytes on a daily basis. Following initial testing, wafers undergo a transformation process, during which chips are extracted using precision diamond blades. Subsequently, these chips are assembled onto circuit boards with fine gold wire, ensuring optimal connectivity. The encapsulation process plays a critical role in safeguarding silicon chips against environmental and mechanical damage. This protective measure ensures their reliability before they are laser tagged for effective identification. Additionally, the factory employs advanced material processing techniques to operate at higher concentrations, transitioning from incineration to recycling. This shift is essential for enhancing waste management practices and promoting resource recovery. Innovative green walls implemented within the factory environment significantly reduce energy consumption. This initiative exemplifies the integration of eco-friendly design principles within industrial settings, contributing to a sustainable operational framework. Finally, the use of renewable energy within the factory is substantial, equating to the power consumption of a small town. This commitment to sustainable practices underscores the factory's dedication to environmental stewardship.